Horizontal launch, problem number 18. A bomber is flying at 200 meters per second at an altitude of 1,200 meters. At what horizontal distance from the target should he release a bomb so that it will land on the target? So this is our airplane, and this is a bomb that is attached to it. So it's flying with a velocity of 200 meters per second, and is saying that if this, let me make a little bit smaller. So this is the target, and this airplane is 1,200 meters above the ground, and is asking what is the distance the bomber should release the bomb that will land on the target. So you should expect first that when it's released, the bomb is going to have this type of trajectory. So if the airplane and bomb altogether is flying with this speed, which means that if we have right here, let's this, and finally it's going to land here. So that means that our bomb, after released, is going to be flying with the same speed, same horizontal speed, and is going to land on the target with that speed. So that is our horizontal speed. Vertically, when the bomb is released, its initial velocity is 0. So as the time goes by, the vertical velocity is going to increase. It's going to accelerate with acceleration of gravity. And that here will be your final velocity. So this is our VVI is 0. And the arrow kind indicates the size or the magnitude of the velocity is going to land with a very higher speed than when it was released. So the entire problem, what is asking is the horizontal distance, or DH. Let's identify this height is our vertical distance, dV. So now we are going to draw two tables. One is horizontal, and the second one is the vertical table. So then we are going to draw the table with the 5 variables, motion variables: velocity, distance, acceleration, and time. So of course we are going to define initial and final velocity here. So our VI, VF, DAT for both tables are the same, and we just need to identify those variables. So horizontally, the initial velocity is 200. When the bomb is released, it will be 200. The final velocity is the same. Horizontally is not accelerating, so our acceleration is 0. Our horizontal distance is dh, and the time horizontally that stays in the air is th. So now let's complete our vertical table. So you have to see this as a vertical motion when it's dropped. So our initial velocity is 0, final velocity is vf. Our distance, vertical distance here is 1,200 meters. Our acceleration is 9.8 meters per second square, positive because accelerating. And our time for vertical is TV. Now, the horizontal time and the vertical time are the same. So TH is equal TV. What I'm looking in this problem is our horizontal distance. So the formula for horizontal distance through this horizontal table, which is not accelerating, is VH times TH. So we have VH, which is 200, and we don't have TH. But because this statement, the horizontal time and the vertical time are the same, so we can calculate the vertical time from this table. So we are using here a simplified version of the second equation that we have in our list, which is dV equal VIT plus half AT squared. So we're going to simplify all that based on the way this table is set up. Our initial velocity is 0. So after simplification, we have 4.9 ATV squared. So our dV is 1,200, 4.9. Sorry, this should not be here. This is not. And, okay, correction. Our simplification here does not include acceleration. So it's just 4.9 TV squared. Just it. So TV squared, right? So we are going to divide both terms by 4.9. So our TV is, use this calculator, 1,200 divided by 4.9 is, our TV square is 4.89. Now you are going to square root both sides, and our TV is 15.65. Okay, so now that we have TV, because you have this statement, so we are going to replace TV right here when we have TH, which is 15.65. So our horizontal distance, so I have here in my calculator, times 200 is 300, rounding, 3,130. And that's my final answer. And that's what the problem is looking for. So let's recap. Our airplane is dropping a bomb because it's flying with the same speed. So horizontally, we have the same values. We have 200 meters per second all the way through. However, vertically, the velocity is going to be affected by gravity. So it's going to start with 0 when it's dropped, and it's going to increase as the time go by. So now that we have an understanding about the two motions that combine together to make just one, so we have this arc trajectory. So our dv here is our vertical distance or height, and our dh is the distance where the bomber needs to drop the bomb and is going to land the target. Then we build these two tables, a horizontal table and a vertical table with the same variables, motion variables. Then we set up the table based on what we see horizontally and vertically. Then we have here two formulas that can help us for horizontal when we don't have acceleration. So we have dh is equal vh times th. And this is a simplified formula for the vertical one when the initial velocity is 0. And then we work with our numbers. We calculate our vertical time. And since the time vertically and horizontally are the same, so we replace this value right here and we calculate our final answer.